Okay, so we're going to identify and apply properties of interior angles of polygons. We'll explain that on the notes. It is, again, the last 9 weeks, so you want to finish strong, and that means doing what you can do in class, and everyone should know what grade they're shooting for. Some of y'all, it's going to be above passing. You want to make sure you're shooting for the right number this last 9 weeks. Okay, now, it also says on here, do introduction to polygons. What we did yesterday is do, okay? A lot of people finished, but if you haven't finished, you can work on that today after the notes. Now, I'm asking you to draw these. Let's remember on number 1. First of all, what is a heptagon? Okay. Heptagon. On the notes we have from Monday, heptagon is a 7-sided figure. It sounds weird, but you got to know heptagon is 7. Cool. Now, what does concave mean? Caved in, kind of name. One of the corners, one of the vertices will be pointing inward. Okay. So concave heptagon. Now there's more than one way to draw this. So if yours looks a little different, as long as it's got 7 sides and it's caved in, it's fine. So here's how I'm going to draw mine. 1, 2, 3, 4, 5, 6, 7. Okay, as long as you have 7 vertices and it caves in, that is a concave heptagon. Okay. So again, concave, caves in, heptagon, 7 sides. Now, what does regular mean on number 2? What do y'all think regular means? We learned this 2 days ago. What? All sides are the same. All the angles are the same. What's an octagon look like? A regular octagon. 8-sided figure. Where do you see one of those probably every day? Like a stop sign, okay? So do your best to draw a perfect stop sign, which I've learned is kind of hard to do just randomly without measuring stuff, okay? I'm going to do my best. That's terrible. All right. Do better than my best. That's still terrible. I have no concept of like what is equal here. That looks too wide though. Whatever. Okay, so let's pretend this is 1, 2, 3, 4, 5, 6, 7, 8-sided figure, and all of the sides are the same, and all the angles are the same. Okay, just do your best. I know that does not look perfect. Okay, but imagine. Okay, if you measured everything out perfectly, it would be regular. Cool. Now, number 3, convex. Unlike concave, convex does not cave in. And irregular means it's not perfectly all the same, right? Now, what's a nonagon? How many sides is a nonagon? 9. Non sounds like 9. So all you gotta do is make a 9-sided figure. If it's convex, though, that's the thing. You don't want to make a cave in. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. As long as you have 9 vertices and it's not perfect, then you have a convex irregular nonagon. Okay. So there you go. So I got small side here, I got a long side here. That's irregular, 9-sided figure. Okay, you just do your best. As long as you know what these words mean. So does everyone understand what concave and convex are, regular and irregular, and you know some of these names? You're supposed to know 3 through 12, okay? Now, what we're going to talk about today is the interior angles of a polygon. All right, here we go. Again, the more you interact with me, the faster this goes. Okay, so very first figure, what is that thing? Triangle, super easy, right? So we know this is a triangle, and how many sides do we have there? 3, super easy, right? Now, this might seem a very silly question. How many triangles are in a triangle? 1, okay? You'll see why this question matters, but for this one, obviously one triangle is just one triangle. That's it. Now let's see what we remember from last 9 weeks. How many degrees are in a triangle? 180 degrees. Everybody, y'all need to know this for the rest of your lives. Inside of a triangle is 180 degrees, okay? So go ahead and fill that in at the very end. 180 degrees. All right, moving on. Second one. Now, I know what this looks like, but what do you call all 4-sided figures? Quadrilateral. Okay, it looks like a rectangle, but it's a quadrilateral also. Okay. Now, it's a quadrilateral. How many sides and angles? Obviously, we have 4, right? Now, here's how you do the next part. How many triangles are there? Well, if you just look at it, I don't see any. What you have to do is pick one vertex. I'm going to pick the bottom left and draw all of your diagonals. You're connecting all of the non-adjacent vertices. So I'm going to connect this to this. And now do you see triangles? Two triangles, okay? Inside of a rectangle. If you're here after 9 minutes, I have to mark you absent. Sorry. Here you go. So again, we have 2 triangles. Let's write that down. My pen just ran out of digital ink again. It's kind of a joke. All right, but seriously, the battery is screwing up here. There we go. Okay, 2 triangles. Now, if I know one triangle is 180, what do you think 2 triangles? How many degrees that going to be? So go and write that down. So 2 times 180 equals 360. Let's do another one. Count the number of sides down here. How many sides do I have? 5. So what do I call a 5-sided figure? Pentagon. Okay. And once again, pick a vertex and connect all of your diagonals. That's it. How many triangles do you see? 3 triangles. So once again, each triangle is 180. So I'm going to do 3 triangles times 180. Okay, and if you're not sure, you can do a calculator over here. 3 times 180 gives me 540. All right, and you might see a pattern forming here. So this next one, 1, 2, 3, 4, 5, 6-sided figure is called what? Hexagon. And let's pick a vertex and draw all of my diagonals. 1, 2, 3. How many triangles do we got? 4 triangles, okay? And again, we're going to take that number of triangles times the degrees, 180. 4 times 180 is, no, not divided, 4 times 180, 720. Okay, now, Two more. Now you might see the pattern already, hopefully, but let's just do these two more, okay? On this next one, I got 1, 2, 3, 4, 5, 6, 7 sides. What do I call a seven-sided figure? Is it a seven-gon? Heptagon. Right. This is the weird one. So y'all got to just memorize this word. Heptagon is 7. And I'm going to take my vertex, connect my diagonals. 1, 2, 3, 4 diagonals. Gives me 1, 2, 3, 4, 5 triangles. Okay. And once again, take those 5 triangles times 180 for each. 5 times 180 is 900 degrees. It's very hot. Okay, last one here before the bottom. 1, 2, 3, 4, 5, 6, 7, 8-sided figure. It's called a what? Octagon, like a stop sign. This is the weirdest looking stop sign. Okay, bless you. So again, pick a vertex. 1, 2, 3, 4. Don't forget 5. And that gives me 6 triangles. 6 times 180. 6 times 180 is 1080. Before the last one, I want to see how old I am. Okay. How many of y'all have ever played a Nintendo 64? Is that like old to y'all? Dang, I remember when that came out. So anyways, back in middle school for me, okay, everyone got the Nintendo 64. And the cool game to play was called 1080. It was a snowboarding game. Because the 1080 is doing 360s. So like you're doing like the snowboard half pipe and you're like 360s, 1080. All right, so that's my story. Every time I see 1080, I think of video games. But that's if you're elder like me. Now, everybody, I hope you saw the pattern. Let's think about this. How do I get from the number of sides to the total degrees? So first of all, how do I get from here to here? What happens each time? It's minus 2. So each side, number of sides, will give you minus 2 triangles. And once I get that number, what did I do with it each time? Times 180. So if I made up a number, 100-sided figure. You don't need to actually draw it. You can take that 100, subtract 2, times 180. Same pattern, right? So we're getting a pattern, so we're going to make a rule at the very bottom here, okay? So here's the n rule. N is the random number of sides. Put n right here. Okay, just work. Put n right here, please. So n number of sides, no matter what the number is, I'm so confused. It won't erase. It won't write. Now it writes, but it won't erase. Oh my goodness. Zoom. Okay, here we go. Thank you very much. Please erase. Thank you so much. Now, everyone with me? Looking up here, please. Okay, if you got a phone, don't look at that. Right. So, what did we do from this? Go ahead and put that in parentheses too. N minus 2. And we already said this on the last column. Every time, what are we doing with that number? We are multiplying it by 180. So our final rule is going to be n minus 2 times 180. Okay, y'all see that pattern every time? Number of sides, take away 2 times 180. Now, what is this thing we just finished with? This is the big deal. I got to scroll to the top. This is for the sum of the interior angles. The sum, the total. Y'all know S-U-M, sum, doesn't mean S-O-M-E. It's not a few. Sum means total. The total interior angles is going to be n minus 2 times 180. So if you flip it over, we're going to write that in our polygon sum conjecture. Okay, so you want to flip that over. We're going to put n minus 2 times 180. Go ahead and underline the word sum. Not one, not each, not a few, the sum, the total sum, okay? So we're on the back page now. Now, let's take this conjecture, n minus 2 times 180, and do some problems with it. If we have a 35gon, how many sides is that? 35. It's in the name, right? So here's what we're going to do. We're going to replace n with 35. So here we go. 35 minus 2 times 180. That is the sum of the interior. Okay, so I can go to my calculator and do 35 minus 2 times 180 in parentheses, 35 minus 2 times 180. I get 5,940. Do you see how that works? Plug in the number of sides, get your sum of the interior. Now, letter B, dodecagon. I'll be impressed. Does anybody remember what a dodecagon is? How many sides? 12. Okay, decagon is 10. Dodecagon is 12. Okay, I'm putting 12 on this. So plug that in because we're looking for the sum of the interior. I'm going to do n, which is 12, minus 2 times 180. 12 minus 2 times 180. And we get 1,800. Cool. Okay, next one. 125gon. Plug it in. 125 minus 2 times 180. 125 minus 2 times 180. 22,140. And these are all degrees. Okay. Now, if they ask you not for the sum, but for each interior, or one interior, or an interior, this means not all of them, but one, right? If they ask you for that, it's a little bit different, okay? What you do is you take this whole sum and divide it by the number of sides, which is n, okay? So if they ask you for one interior, each interior, whatever, you're going to take this divided by n. Let's go ahead and write that down. n minus 2 times 180 divided by n. So everyone's writing this down. N minus 2 times 180 divided by n. Now, this number 1 right here, a decagon is how many sides? 10-sided figure, right? Regular, what do we know about the side lengths? And what do we know about the angles? They're both congruent. The side lengths are all congruent. The angles are all congruent. Go ahead and write those two down real quick. That's what regular means. Everything is the same. Everything is congruent. Now, let's letter C. Do you see how it says each interior angle? What is the measure of each interior angle of a regular decagon? I'm not using the sum equation from the top. I'm going to use this new one right here, okay? Because it says the word each. So I'm going to plug in 10. 10 minus 2 times 180 divided by 10. So let's do that. Control divide. Ten minus 2 times 180 divided by 10. Hit enter and you get 144. That means each and every interior angle of this decagon is 144 all the way around. You don't have to write it, but this is what it would look like. All right, each interior. So remember, when you divide by n, that's each. When you don't divide by n, that's the total, that's the sum. Let's do one more example of that. If it's a regular 25-gon and you're finding each interior of a regular 25-gon, you're going to use the same formula, okay? So here we go. 25 minus 2 times 180 divided by 25. Now, if you get a fraction like that, make sure you hit Control Enter. And I get a decimal, 165.6 degrees. So do you see how I'm using that new formula for each interior? Okay, last one here. How do you think I want to find E? Any idea? 5 minus 2. 5 minus 2? Oh, you're using that formula. Okay, to find what? 5 minus 2 times 180. Okay, 5 minus 2 times 180 gives you, oh, what does that give you? No, number-wise, what is that thing that you find out of the whole thing or what? Good, the whole thing. So everybody, you can't find the missing one unless you know what all the others. You're right. You want to do n minus 2 times 180. That's called the sum of the interior angles. The top of this page. Sum of the interior. So that's what we're going to do. What is this called? How many sides do we have? 5-sided pentagon. So n's 5, right? N equals 5. So let's do 5 minus 2 times 180 to get the sum. What is 5 minus 2 times 180? I got 540. So that means all these angles have to add up to 540. Okay. Sorry about this. Okay. Now I'm going to put an X on my E. That's what's missing. An X there. And what I'm going to do is I'm going to add up everything equal to the total. So I'm going to make a long equation. So 81 plus 108 plus 135 plus the other 81 plus X. All 5 of those angles adds up equal to 540. Now, I set it up algebraically, but you might already know this. If you just add up the ones you know, subtract it from the total, you get what's missing, right? Well, that's what I'm going to do right now. Let's add up all 4 of these numbers, 81, 108, 135, and 81 again. I get 405. When I combine these 4 like terms, I get 405. Bring down plus X equals 540. Okay, and then last step, to get rid of that 405, I subtract 405. 540 minus 405 is 135. Agrees. Do you see how you can find a missing angle? If you know the total, add up what you know, take it away from the total, you get your missing angle. Now, you're not going to have one like that on today's assignment, but you are going to be finding the sum of the interior angles and then each interior angle of a regular polygon on this assignment. I'm going to pass it out now.